Hi everyone, I'm Patrick from UC Berkeley. Today, I'm happy to present our work, See, Say, and Segment, teaching LMMs to overcome false premises. Recently, people have adapted large language models to large multimodal models, LMMs, by adding additional image inputs and optional visual outputs. These modules excel at producing segmentation masks given complex image grounding queries. However, we found that these models often struggle when fed with false premise queries, i.e., objects that doesn't exist in an image. For example, if you ask them to find a bottle of pineapple, traditional methods will still tend to produce a hallucinated mask that's obviously not what we want. To address this, we develop a new method called SESAME that not only rejects these incorrect queries, but also provide valuable feedbacks by correcting them and generate segmentation mask. So, let's dive deeper into our work. First, we define a new problem setting. Given an image and a textual query, the model needs to see by verifying the object presence, say by producing useful feedbacks, either rejecting or correcting a query if that doesn't exist. And finally, segment by generating segmentation mask for all true query. Our intuition is that an ideal system should gracefully deal with false premise queries, and that is very important in our real-world applications. To support the new task, we then introduce a new benchmark dataset, FKRevCoco. This dataset contains an equal number of true and false premise queries with diverse GPT-generated templates. For true premise queries, the output is a segmentation mask sourced directly from the RevCoco data. For false premise query, we use the LLM to augment these data and ask the model to correct them back to the ground truth phrases. Specifically, given the true referring phrases, we use GPT 3.5 to produce the false premise queries. Prompt with guidelines and in-context examples, the LLM can generate semantically similar false premises like similar objects, attributes, or relations. These data are more diverse and reasonable for the false premise correction task compared with existing data that directly sampling categories from COCO. In terms of solution, we start with a naive one by training multiple off-the-shelf LMMs. A general Lava model for See and Say, coupled with a segmentation specialized model like Lisa for actual segmentation task if object exists. After that, we train a comprehensive LMM called SESAME that can handle all these aspects. Initialized with Lava weights, the model is fine-tuned with our FPRevCoco data alongside traditional reference segmentation and VQA datasets. Here comes three experimental results. On our benchmark, we evaluate See, Say, and Segment capabilities respectively. As you can see, our comprehensive SESAME model achieves a better performance than training methods and hugely outperforms existing baseline Lisa. Interestingly, Lisa is actually the model fine-tuned from Lava, so the results also highlight that, without proper fine-tuning, the LMM can suffer from catastrophic forgetting. On conventional reference segmentation tasks without false premises, the SESAME model also achieves on par performance with our state-of-the-arts. So here are other visualization results. As you can see, our methods can handle relevant objects, irrelevant objects, similar attributes like color, or analogous concept and evenly activities. And it is very impressed that our models can handle really complicated reasoning instructions. For example, for the first two queries, with conditional segmentation tasks, prior methods just cannot understand, but the SESAME can do pretty well. For the last examples requiring only QA, SESAME can understand that we don't need to produce segmentation mask at all. So here's the contribution. First, we propose a new problem setting requiring model to do See, Say, and Segment. And then we also introduce a new benchmark dataset and also achieve the best performance on that. So don't forget to scan the QR code for the open source code base, dataset, and paper. Thanks for listening.